Hello! In this video, we present the synthesis of dideuterated diazepam, following the retrosynthesis that was presented in our previous video. This isotopologue may prove to be beneficial for the investigation of the pharmacology of this drug, and it can also serve as an internal standard reference for bioanalytical methods. This synthesis has unlabeled diazepam as its key precursor, and it is obtained from a relatively novel intermediate for the synthesis of benzodiazepines, a benzisoxazole, which then gives rise to a substituted benzophenone. The heterocycle, for its part, can be derived from raw materials which are commercially available, as we will see later. The nucleophilic aromatic and regioselective addition to chloronitrobenzene 1 is facilitated by the presence of the nitro group to react with the conjugate base of phenylastenitrile, which is formed by using sodium ethoxide so that it can then produce intermediate 3. This compound then undergoes aromatization in the presence of the base, leading to the formation of intermediate 4. The abstraction of hydrogen in 4 by the base generates intermediate 5. The intramolecular addition of the oxyanion, which is then followed by the subsequent movement of electron pairs, forms heterocycle 6, which through the elimination of the nitrile group then generates benzisoxazole 7. We can note the functions of the nitrile group within this reaction sequence. Initially, its primary role is to stabilize the resulting negative charge on the carbon atom of the phenylacetonitrile, and then, in a subsequent step, it functions as a leaving group for generating the heterocyclic ring. The heterocycle is opened when treated with iodo-trimethylsilane to produce orthoamino-benzophenone 8. The heterocycle functions as a means to obtain the benzoyl group and the amino group in an ortho relationship. The reaction of compound 8 with chloroacetyl chloride then produces the chlorinated compound 10. The reaction involving compound 10 and ammonium carbonate results in the nucleophilic substitution of the chlorine atom by ammonia, thereby yielding amine 11. And in the reaction medium, the amino group intramolecularly attacks the carbonyl of the benzoyl group, leading to the formation of benzodiazepine 12. The methylation of the nitrogen of the lactam in 12 is accomplished using methyl iodide, yielding diazepam. In order to optimize the deuteration process, the indicated nitrogen is protected as the N-oxide by treatment with peracetic acid to generate chlordiazepoxide 15. The treatment of compound 15 with deuterated sodium hydroxide initially generates the lactam enolate, which, when subsequently trapped with deuterated methanol, and by repeating these transformations, they achieve the introduction of 2 deuterium atoms into the alpha carbon of the lactam. Finally, the chemical reduction of the N-oxide group, utilizing phosphorus trichloride, generates the dideuterated diazepam, exhibiting an excellent deuterium incorporation. In summary, here are the main raw materials and their structural contribution. Thank you for your attention.